Given an inequality, an equivalent inequality can be obtained. So we had an equal sign, both sides are equal. Now we've got an inequality, but you can kind of solve it so that both sides, it's still true on both sides. And you do that the same way we would with an equation, adding or subtracting from both sides. Multiplying or dividing, again, both sides. By a negative number and reversing the inequality symbol. So that one I'm going to have to show you. If I have 2x plus 4 is less than 10, well, if I take off that plus 4 from both sides, 2x is still less than 6. That's going to be true, and then x will be less than 3. We still don't know what x is, but that inequality is now still true. If we have negative 4x plus 2, of course we want to get rid of the plus 2 first by subtracting it from both sides. Now we've got negative 4x. This is the trickiest bit. Negative 4x is less than 4. We divide by negative 4, and look what's happened. We get a positive x, but this is where we have to do the swap C. So it was negative x is less than 4, and now when we divide by negative 4, when you divide by a negative, x becomes greater than negative 1. So the sign is reversed when you multiply or divide by a negative. That's really important. For this one, 2 is greater than x plus 1. I can take away 1 from both sides and get 1 is greater than x. Or I can just, do you notice how on an equation you have a left-hand side and a right-hand side and you can just switch them? If you're going to just switch them, 1 is greater than x, you got to switch the sign with it. You've got to turn the whole thing around. So you've got 1 is greater than x, or x is less than 1. They both say the same thing, but you have to maintain that relationship. I'll keep going, and then we'll have questions afterward. So for this one here, we've got 5x plus, I'm going to write it out again. 5x plus 2, whatever that is going to be less than 47. So I solve it like I would any algebraic equation. To start with, I've got 5 x's are less than 47. That's a very loose less than. And then I divide by 5 to get 1x. And, 45. And then I divide by 5, and I get my answer is x is less than 9. I might have to spread these out a little bit. So here I've got 3 plus 4 x's. The whole thing is being divided by 9, and it will end up greater than or equal to 3. So thinking back to what we do with our algebra, if I've got the whole of the top divided by 9, I can multiply by 9 on both sides. That leaves me with 3 plus 4 x's, keeping the sign. It's greater than or equal to, what is that, 27. And remember, I'm trying to untie and undo everything that's happening to the x. I haven't had to do any swapping or changing of sides yet because we're dealing with positive stuff. If I take 3 off this side, I'm left with 4 x's being greater than or equal to. Take 3 off that side, and I've got 24, and you can probably see where this is going. 4 x's divided by 4 gives me 1x is greater than or equal to, divided by 4, 6. So very much like an equation, the only tricks come when we start bringing in the negatives. And so that's an example here. I'll have to put c over here. c is 15 minus 2x, or plus negative 2, is greater than 1. So we can take off the 15. That gives us negative 2x is greater than. Minus 15 gives us what? Negative 14. And then what are we going to do? It's not the subtracting of the negative, it's the dividing. If I divide to get a positive x, divide by negative 2, I get an x. And what am I going to do with that sign? It was greater than. It now does a swapperino and becomes less than. Negative 14 divided by negative 2 gives us the number 7. And there you go.